Okay, so looking at this, if we look at the right-hand side, that's 1 over cos 2x. There's not much more you could do with that. You could say that's 1 over cos squared x minus sine squared x, if you use the cos 2x rule. The left-hand side, the most you can do here is make that cos x on sine x plus cos x plus sine x on cos x, sorry. That'll be plus sine x on cos x over cos x on sine x minus sine x on cos x. And that's just replacing like the tan x, which equals that. And then if you replace the other one, which is the cot will equal cos on sine and cos on sine. Okay, so get a common denominator on the top and then just do top divided by bottom. So on the top, the common denominator here would be sine x cos x, and what you do to the bottom, you do to the top. So you times the cos x by cos x, and the sine x by sine x. So that's cos squared x plus sine squared x divided by, now on the bottom the same, cos times cos will give you cos squared x, sine times sine will give you sine squared x. They've got x, not theta. And that's all over sine x cos x. Now cos squared plus sine squared, that's this one, is equal to 1. So I'll just abbreviate that to 1. So it's 1 on sine x cos x. And then if you look to the right side and you look at that fraction, this one, it's division. So you look to the right side when you divide and you flip and you multiply. That's cos squared x minus sine squared x. Now you can cancel in a fraction anything on the top with anything on the bottom. So they cancel and give you a 1. 1 times 1 is 1. 1 times cos squared minus sine squared x is cos squared x minus sine squared x. And on the left-hand side, that should be an x. On the right-hand side, you have the same thing. So equals the right-hand side, proven.